So in this question, we are given two concentrations, one with molarity and a pH, and the other with just a KSP. First step is to write your equation out, just like I've done here. So we have our KSP equation would be, don't forget your X and your 2X. So KSP is going to be the concentration of our Fe2 plus times the concentration of the OH minus, and that quantity squared. Now let's put in our x's, and 2x squared. So our KSP, our 8 times 10 to the negative 16 divided by 4, and x times x squared is the cubed. So the cubed root of this quantity will give us x, which equals 5.85 times 10 to the negative 6. So 5.8, actually 5.85 times 10 to the negative 6. Now let's keep track of what that number actually means. So the maximum concentration of Fe2 plus that we can have is 5.85. It's just x. 5.85 times 10 to the negative 6. And the maximum concentration of hydroxide I can have is going to be 2 times that, because 2 times x, and that gives me 1.17 times 10 to the negative 5. So this is the most I can have in concentrations of each ion before I form a precipitate. So now let's look at the other information we have. We have 1.2 molar of FeCl2 with a pH of 8.55, and I'm going to combine these two solutions to figure out if and I want to know if a precipitate forms. So the first thing I look at here is like, okay, I'm working with FeOH2. I have a pH, so I can immediately go to the concentration of OH and see if that number is bigger than this. So let's do that. To do that, it is 10 to the negative POH equals my concentration of OH minus. And that's simply because 10 to the log will give me just 1. It's a way of getting out of the logs. So that gives me 10 to, oops, let me do this, sorry. So 14 minus the pH, 8.55, gives me my POH. And remember, this is our KW kind of value. And that gives me what? 5.45. So 10 to the negative 5.45 would give me my concentration of my hydroxide, which comes out to 3.55 times 10 to the negative 6. So that's my hydroxide concentration. Oops. OH minus. So let's see if that went over. Nope, we are smaller. 10 to the negative 6 is indeed smaller than 10 to the negative 5, so the hydroxide isn't going to be the issue. Now we need to look at what we have with our FeCl2. So FeCl2, when we put that in solution, will give us Fe2 plus 2Cl minus. So there's 2 here, but we're not worried about the chloride ion. That's not a competing ion for our common ion effect. We are worried about our Fe2 plus. We have 1.2 times 10 to the negative 3 molar of this, of our FeCl2. That means I have 1.2 times 10 to the negative 3 molar of this. So that's my concentration of my iron. So let's see what that does to things. We come back here, 10 to the negative 3 is indeed larger than 10 to the negative 6, and now you're thinking, bummer, I should have started there. Which is fine. Either way, I mean, you might notice immediately that the concentration of Fe2 plus is going to be the same as your concentration that you're given for this solution. Or if you key in on the OH, I mean, you really only wasted maybe a minute of time. So it's not a big deal. So you come over here and you say, yes, a precipitate will form. Yes, it will precipitate. And there's that.